Square root of a number x is a number which, when multiplied by itself, gives x as the answer or the product. Now, how do we calculate the square root of a number between 1 and 99.99 using square root tables? We have these two examples to work. The first one wants us to work the square root of 5.635 and then the square root of 6.35. You need to note that square root tables are of two sets. There is that which gives square root for numbers between 1 and 10, and there is that one which gives square root of numbers between 10 and 100. Looking at the number we have here, 5.635, this number lies between 1 and 10, and therefore we shall look for its square root in this table. Now look for 5.6 along the x column. You will realize it's here, and then look for this 3 from here up to here. You realize it's here. The intersection of these two will give us the square root for 5.63, and that is actually 2.3728. This 2 is a whole number which operates on, or which belongs to all these other numbers here. In other words, whatever numbers that we have in the table, inside the table, is the decimal part after 2. So this number is 2.3728. Then this 5 is looked for here. Whatever value we shall read, we add. Now you will notice that the number corresponding to column 5 is 11. So we shall add it to this. And what we get is 2.3728 plus 11. We write this 11 to the extreme right because it is actually a decimal value. It's actually 0.0011. So we write to the extreme end, to the extreme right, like that, like I've done here. That gives us 2.3739. So that means that the square root of 5.635 is 2.3739. Now, if you look at the second question, we have 56.35. 56.35 is not, or does not lie between 1 and 10, but it rather lies between 10 and 100. That's why we are using this next table here. So look for 56, you will get it here. Look for 0.3, it's here. So the intersection of the two will give us 7.5033. And then the last digit 5 will be looked for here, and if you look for it, you will get it here. The intersection of this and 56 will give us the number to add to this one, and that is 33. So the square root for this number will be 7.5033, the one I read from here, or the one we read from here, 7.5033, then plus 33. This 33 is written to the extreme end, and that gives us 7.5066. That means that the square root of 56.35 is 7.3066. How do we calculate square roots for numbers less than 1 or numbers greater than 99.99 using tables? To do that, we need to follow these steps here. The first one is to write the number in the form b times 10 raised to power m, where b is a number between 1 and 99.99 and m is an even number. After that, we shall split the expression, and then the third step is to find b from the tables and divide m by 2. So we have these examples here. How do we work the first one? Now you realize the first one is square root of 665.78. Square root of 665.78. This number is greater than 99.99, and therefore we have to follow these steps. So the first thing is to write the number in the form b times 10 raised to power m. This number can be written in this format by simply jogging around with the decimal point. In other words, moving the decimal either to the left or to the right in an effort to make the number achieve this limit. So if we move the decimal one step to the left, we shall have 66.578 times 10 raised to power 1. We can also move it further and get 6.6578 times 10 squared, because we shall have moved the decimal 2 steps to the left, so it will be times 10 squared. We can even move it further up to here. In that case, we shall have 0.66578 times 10 raised to power 3. Now, amongst these three, only one of them satisfies the condition that we have. Looking at the first one, the power is not even. Therefore, this one is disqualified. The third one, the power is also not even, and therefore we disqualify it. So although this one is between 1 and 99.99, the power has made us eliminate it. This one is less than 1, and therefore we eliminate it, besides the fact that the power is also not even. So the only number that remains here that satisfies the condition is this one. This one is between 1 and 99.99, and the power is even. Therefore, we now write 665.78 in terms of this as like that, 6.6578 times 10 squared. The next step is to split the root. So we have split the root, and you can see we have assigned a root to 6.6578 and then times square root of 10 squared, like that. After that, the third step is to get this number from the table. And then for this one, we have to divide the power by 2. So that's what I've done here. The square root table gives this value as 2.5804. And then this one, when you divide by 2, you'll get it raised to power 1, because 2 divided by 2 is 1. Now you notice up here that there is no way you can read all these five figures from the table, so we need to round it to 4 significant figures, and that's why through this 8 we have rounded 7 to 8, because once this number is more than 5 or more than 5, you round the number here, you add 1 to this number here. So we have added 1 to this to make it 8, and this is the value we read from the table. When you read it from the table, you get this figure here. Then for this one, we have said we divide the power by 2, giving us 10 raised to power 1. So this times this gives us 25.804, and that is the square root for this one. What about the second one? The second one was root 0.0096578. We follow the same steps. The first one is that we write this number in the form b times 10 raised to power m. So that's what we have done here. If we move the decimal, in this case we shall move the decimal to the right. If we move it here, we shall have 0.096578 times 10 raised to power negative 1, because we are moving the decimal to the right. We can also write it in this other formats. We can move, in other words, we can move the decimal from here to here. That means we shall write 0.96578 times 10 raised to power negative 2 or we can move the decimal from here to here, giving us 9.6578 times 10 raised to the power negative 3. We can move it from here to here, and we shall have 96.578 times 10 raised to the power negative 4. Or we can move the decimal from here up to here, and that will give us 965.78 times 10 raised to the power negative 5. Or we can move it from here up to here, and that will give us this number. But upon scrutiny, we realize that we shall eliminate this one, we eliminate this one, and we eliminate this one. And what is the reason for that? It's because the powers are not even. So what remains is this one, and this one, and this one. Now we come to this section. You realize the number here must be between 1 and 99.9. This is less than 1, we eliminate that. This one is between 1 and 99.99, so it's meeting the two conditions. This one is not meeting because it's more than 99. That means we shall write this one in terms of this. So we shall have square root of 0.096578 being written in this format. The next step, of course, is to split the root, which we have done. We have square root for this one times the square root for this one. And then now this is the one that we read from the table. And then for this one, we divided the power by 2. Now from this one from the table is this value. If you read it from the table, you'll get this one. Remember, this 41 here is not a whole number. This is a decimalized number. That's why we are writing it to the extreme right when we are adding. And that gives us 9.8275. This is the square root for this number. Then times 10 raised to the power negative 4 divided by 2. We are dividing by 2 because we are looking for its square root. When you do that, you will get 9.8275 times 10 raised to the power negative 2. This one means this 10 times 10 raised to the power negative 2 can be written as 1 over 10 squared. So that's why I've changed it like that. And that is the same as 1 over 100. When you multiply this by this, you'll get this as the answer. So that is the square root for the number that we have up here. With the time, you realize that we don't have to write all this when we are trying to identify the number that we shall use in getting the square root for this. You just have to ask yourself, how can I move the decimal to either here or here so that I meet the two conditions. The number is between 1 and 99.99, and the powers associated with that number is even. So those two values, the moment you identify those two formats or those forms, two forms of writing this number, you realize that one of them will meet the two conditions and it's the one you use. So we have this example here. If we are to evaluate this, then how do we work that? Now, you realize that we have to move this decimal from here to here, or from here to here for us to have this number meet the expectation for B. In other words, for it to be between 1 and 99.99. So that's why I've moved it in two instances. The first one is when I've moved the decimal from here to here, giving us 3.245. In so doing, how many numbers have we skipped? We have 1, 2, 3, 4, 5, 6 digits we have skipped. That's why we have 10 raised to the power negative 6, because we have moved the decimal to the left, to the right, sorry. Then the other instance is when we bring the decimal here. In that case, we shall have the number as 32.45 times 10 raised to the power negative 7, because we shall have skipped 7 digits from here up to here. Now, amongst these two, which one meets the conditions that we set? It's actually the first one, because the second one, although this number is between 1 and 99.99, the power is not even. So this is the number we use. So you can write this one, the square root of this, as the square root of these two. That's what I've done. And in that case, after we have written it, the next one is to split this expression, which we have done. Look for this number from the square root table and divide this power by 2. The square root table gives this number as this, and when you divide this power by 2, you get this. So you multiply this one then times this one, because this is 10 raised to the power negative 3 written in a fraction form. And when you do that, you will get this as the answer. So that is how you can work it out without listing all of them.